So, good morning, good afternoon, everyone, and welcome to this lecture. We are dealing with electric flux and Gauss law. Do you remember? We had dealt with electric flux in our previous class. We had seen when the flux is going to be positive, when the flux is going to be negative, and when the flux is going to be zero. Yes or no? Electric flux is a scalar quantity, and I think I told you the SI unit of electric flux as Weber. That is a wrong thing. For me, this Weber is the magnetic flux, not electric flux. So you just take this of it. Magnetic flux, the SI unit is Weber. I don't know what I was thinking at that point in time. I just remember that I told you that electric flux is Weber. It's not Weber. It is Newton's coulomb per meter square. The SI unit is not Weber. So please remember it. Just correct the thing. And maybe in some other universe where electric flux is called Weber. Okay, so just correct it. And we had seen electric flux is a scalar quantity, so it can be positive, it can be negative, it can also be zero. Yes or no? Depending on the angle between the electric field and the area vector. I told you about closed surfaces and I told you about open surfaces. Did I tell you about closed surfaces or open surfaces or not?
Yes, sir.
I told you that anything that encompasses a volume, which has a volume, this thing is a closed surface. And if it is like this, it is an open surface. Yes or no? You
Yes,
understand
sir.
this? Now, since we have understood what is a open surface and a closed surface, we can now move on to what is known as the Gauss law. Any idea what is Gauss law? Any idea what is Gauss law? Tell me. Yes. What do you mean by like has anyone seen? Has anyone understood or know what do you mean by Gauss law? Yes or no? Gauss law, has anyone heard about Gauss law? Hmm? Okay. Now this Gauss law, remember, it deals only with a closed surface. So that is the first thing that you must understand about Gauss law. This Gauss law is only valid for a closed surface. Now, what does this Gauss law say for a closed surface? For a closed surface, Gauss law states that the total flux through any closed surface is equal to charge enclosed divided by epsilon naught. Now, to write it looks very difficult, but to write it in equation, it is very simple. Flux through any closed surface is equal to the charge enclosed by the surface divided by epsilon naught. This is what we call as the Gauss law, and it is valid for any charge, any surface, anywhere in the universe. If it is vacuum, you will divide it by epsilon naught. If it is not vacuum, you will divide it by epsilon, the relative, the permittivity of the medium. It is valid for any type of closed surface. So if this is the closed surface and you place this closed surface anywhere in the universe, and if someone asks you what is the electric flux through this closed surface, what you got to do is just check how many charge are inside, find out the total charge and divide it by epsilon naught. Do we understand this? That
Yes,
is what we call as the Gauss law. Remember, what is the point to remember here? It is only valid for closed surfaces. It is valid for any size or shape placed anywhere. So it does not depend on the size or the shape of the surface. You place it anywhere. The Gauss law is valid. Do we understand this? Yes or no? No, yes.
yes, sir.
Now, if I give you an example, say this is a closed surface. Now, any closed surface on which Gauss law is applied, that closed surface, this is a closed surface. That closed surface can be called as the Gaussian surface. That closed surface can be called as the Gaussian surface. So any surface which is a closed surface and you are trying to apply Gauss law on that surface, you can call that surface as a Gaussian surface. So suppose this is a closed surface, a Gaussian surface. There are some charges, let us say plus Q1, minus Q2, minus Q3, plus Q4 coming inside this surface. Then there are some more charges. The universe has a lot number of charges. Q5 is outside, minus Q6 is outside, Q7 plus Q7 is outside. So if someone asks you, what is the flux through this closed surface? What is the flux through this closed surface? So your answer would be flux through the closed surface will be equal to how much? The total charge. How much is the total charge here? There are some positive charges and some negative charges. So you have to find out the total charge. What will be the total charge here?
0, sir.
The total charge here will be Q1 plus Q4 minus Q3 minus Q2 minus Q3. That is the total charge closed in this Gaussian surface divided by the epsilon naught. This would be the electric flux through this closed surface which I have created. It is only valid if the surface is closed. It is not valid if the surface is open. Do we understand this?
Yes, sir.
Give you 2 minutes to note this down. Anyone has understood this? Yes or no?
Yes, sir.
Have you noted it down?
Yes, sir.
Now, there's another way of writing this Gauss law. So we can also see that way. Remember, the flux through a closed surface can be written like this: E dot ds. I told you flux is the integral of E and ds. So you can write it like this: So you can write it like this. Now, whenever you put this gola on the integral, this round on the integral, this round means that the surface is closed. This round symbol on the integral means that the surface is closed. Do we understand this?
Yes, sir.
Is equal to the charge enclosed inside the surface divided by epsilon naught. Now remember, we have this electric field E on the left hand side. This electric field is the net electric field created by all charges of the universe. So on the left hand side, we have the net electric field created by all the charges in the universe. This is E net. Net electric field created by all the charges, E1 plus E2. Do we understand this? Whatever charges are there in the universe. This is the net electric field created by all the charges in the universe. But on the right hand side, I only have charges which are there inside this. Do we understand this? That is the beauty of Gauss law. That is the beauty of Gauss law, that whosoever creates electric field doesn't matter. What matters is how many charge I have inside this. Do we understand this?
Yes, sir.
You have 2 minutes to note it down. Once you are done, please let me know. Are we noting it down, bacha?
And sir.
Everyone, sir? Boys? Huh? Boys, what are you doing? Chilling out? Abhiram has done. What about the other boys? Chilling out, everyone?
Yes, sir.
Let's chill out. This is the time to chill, man. No, na? This is not the time to chill. This is the time. I mean, weather-wise, it is the time to chill, but otherwise, it is the time to study. So these are the things that you must remember about what? Gauss law. It is valid for only closed surfaces. Any type of closed surface, it is valid. Electric field is created by all the charges in the universe, but charge, we only include those charge which are coming inside the what? The surface which is enclosed. Now, in some cases, the electric flux is always going to be zero. So you can write that heading, electric flux is zero if. So you can write some special cases. Electric flux is zero. In what all cases will you find that the electric flux is zero? This is case number 1. If you have a dipole, you don't know what is a dipole. A dipole is an arrangement of two charges. You can see here two charges, green charge and the pink charge of equal magnitude but opposite sign. If you have a dipole inside a surface, the flux would be zero. You can draw the diagram. Draw the diagram and remember it. All these are possible questions that are going to come in your exam, my dear friends. Second case, if the magnitude, just first listen to me, then you can draw the diagram. The second case, when you have equal positive and equal negative charge, we have 2 coulombs of positive charge and 2 coulombs of negative charge. In that case, the total charge will be 0 and the total flux would be 0. Do we understand this? Huh?
Yes, sir.
Third case and the most important case. And you will have questions based on this case. So first, I will just give you everything and then you can. Okay, do one thing. First, note down these two. No, I can put this one as well. Flux is 0 in what all cases? You have seen 2 cases, and the third one is, remember, it's a very important case. If a closed body which does not have any charge is placed in a electric field, whether the electric field is uniform or non-uniform, there is no charge inside it, the flux would be 0. Do we understand this? If it does not have any charge through any closed body, you place it, the total flux would be 0. Do we understand this? Yes or no?
Yes, sir.
Please note this down. I'll give you 2 minutes to do it. Have you noted it down, bacha?
Done, sir.
Boys? Huh?
Yes, sir.
Yes,
sir. Yes, sir.
Done, no, sir?
Completed, sir. Completed, sir.
Completed, na, sir? And tell me, na, sir, so that I can move ahead in life.
Sir, mic is not working.
Okay, okay, okay. ठीक है, चलो. Completed, sir. I will move ahead, sir. Now, The next thing, again, remember, flux linked with a body does not depend on the size or the shape of the body. So that is the next point that you will have to see. The flux does not depend on size and shape of the body, of the closed body or the closed surface. In the first case, you can see it's a random closed surface. The flux, total flux is Q by epsilon naught. In the second case, you have a sphere, closed sphere. The flux enclosed is Q by epsilon naught. In the third case, you have a closed cylinder. The flux enclosed is Q by epsilon naught. In the fourth case, you have a closed tube. The flux is Q by epsilon naught. It does not depend on the shape of the body. It only depends on how much charge is inside this. Do we understand this?
Yes, sir.
Okay. Note it down, please. Let me know once you are done, bacha, so that I can move ahead in life.
None, sir.
Completed, sir.
Okay. Now, we are seeing important points about this. And write the next important point. If the flux enclosed through any closed body is zero, that implies the net charge in the body is zero. Do we understand this? There is no net charge in the body. It does not imply that the electric field is zero. Do we understand this? Yes or no?
Yes, sir.
So if you are finding that the total flux through any closed surface is zero, that means there is no net charge in the surface. That does not mean that there is no electric field there. There can be electric field, but the net flux is zero. That means whatever is coming inside, the same electric field, the same number of lines are going outside. Do we understand this?
Yes, sir.
Okay. From this comes a very important point. I hope everyone has noted this down.
Yes, sir.
Please note this down. If a closed surface is placed in a uniform field, the flux through that closed surface should be equal to 0. That closed surface should not have any charge. We have already done this. Yes or no?
Yes, sir.
Okay. Now, there are some sample important points that you can note down. Some important cases of flux which might come in your exam. So we'll note down as important cases. And one of these case might come in your exam. Case number 1, like this. A hemispherical body. Remember, if it is a closed body, the flux is 0. If it is not a closed body, so it is open from the top, it is a hemispherical cup like this. Do you understand this? It's a cup like this, hemispherical. So it's an open body. If it is placed in a uniform electric field, then the flux through it will be uniform electric field when it is going like this. Then the flux through this is pi r square into E. The flux through this is pi r square into E. But if the electric field is going like this, it is known as radially outward. It's going on as radially outwards. Then in that case, the flux would be 2 pi r square into E. I hope you are able to understand the difference between the two diagrams. Do we understand this?
Yes, sir.
Have you written it down? I'll give you one more case here. The case that comes in most of the cases. This one, a charge is placed at the center of the cube. What is the flux through the entire cube? Remember, the flux through the entire cube is q by epsilon naught. A cube has 6 faces. It is equally divided. So through any face, it will be q by 6 epsilon naught. Through any corner, it will be q by 8. Through any edge, it will be q by 12. Do we understand this? Yes?
Yes, sir.
This is all that you need to know about this Gaussian surface and cubes, and these are all the problems you might encounter in this. I'll give you 2 minutes to go through this. Everyone is noting now? All these are potential questions, beta, that are going to come in your exam. Everyone has noted this, bacha?
Yes, sir.
Boys?
Yes, sir.
Now we can come and solve a couple of problems on this. This is problem number 1. Came in one of the previous exams. Electric charge is uniformly distributed along a straight wire of radius 1 mm. The charge per centimeter of the wire is q coulomb. Another cylindrical surface of radius 150 centimeter and length 1 meter is placed symmetrically, encloses the wire. So it is enclosing the wire. What is the total flux passing through the cylindrical surface? You have 1 minute to do this and get me the answer. I hope you understand the question, bacha. Yes or no?
Yes, sir.
You have to find out the flux. And I hope you understand what this question is meaning. Yes, bacha. Do you understand it, beta?
Sir, option B.
Option B. How did you get option B? Tell me that. Why not any other option? Why option B? Option B. So basically, you have to find out how much charge is coming in this cylinder. Yes or no? We
Yes,
just
sir.
have to find out what is the length of the cylinder. Is 100 centimeter multiplied by how much charge is coming in 100 centimeter. 100 into q, because charge in 1 centimeter is q. So 100 q divided by epsilon naught. The only answer that matches is this one. That is the correct answer. Do we understand this, or this is going about it saying bye bye, bye bye, bye bye?
Understood, sir.
Everyone understands this? Yes or no? Huh? Anyone
Yes, sir.
understand? Pakka?
Yes, sir.
Here comes the next question. Find the charge. Find the flux through this Gaussian surface. I have created a spherical Gaussian surface. Something is given. What is the flux passing through this Gaussian surface? That is the question, my dear friends. What is your answer? I am worried about your answer. What is your answer? The simple question, bacha. And I wait your answer patiently. What is the answer, bacha?
Sir,
Yes.
sir, what should find?
You have to find out the flux, beta. And what else? What is there to find out? Apart from the flux. What
Zero.
else? The only thing you can find out is the flux, bacha. Nothing else is there. Yes, what is the answer?
Zero, sir.
And how did you get 0, sir?
Sir, charges are enclosed in the inside the circle.
That is not a circle. It is a closed surface, beta. That is not a circle. It is a closed surface.
Okay.
So the total charge that is coming in that closed surface is 0. Circle is not a closed surface. Remember, circle is not a closed surface. So this is a sphere. This is a closed sphere. And the net charge coming in this sphere, this is minus q here and this is plus q here. So the net charge becomes 0. Therefore, the flux through this closed surface will be equal to 0. Do we understand this? Yes or no? No, yes. Huh?
Yes, sir.
Everyone understands this? Can I have raise hands from everyone in the class? That we understand this, boys, girls? So remember, the flux would be 0 only if the charge enclosed is 0. Can I give you the next one in the line?
Yes, sir.
And again, this is a very famous question. It has come many times, and if you're lucky enough, you might also find the same question in your examination hall. So this is a very famous question. You have this half hemisphere or hemispherical cup, and you have a point charge placed at the center of this hemisphere or hemispherical cup, and they ask you what is what is the flux through this hemisphere. It's an open hemisphere. Circular part is opened. They ask you how much is the flux. Yes, my dear friends. What is the answer for this one? Do we have any answer? Eh? Give you 2 minutes to think about it. So how are you going to do this? Whenever you get such a
Q
question,
by epsilon naught, sir.
not Q by epsilon naught beta. Whenever you get such a question, you think about symmetry. Gauss law is always about symmetry. Now, you have to find out the flux through half of the sphere. Instead of finding the flux through the half of the sphere, what you do, you put the other half on the top of it. Once you put the other half on the top of it, now the flux through the entire full sphere, which is here, the flux through this entire full sphere will be Q by epsilon naught. Yes or no?
Yes, sir.
Now this is divided equally between the upper half and the lower half. So what will be the flux through the lower half? That is what we wanted to find out. So what will be the flux through the lower half? It will be the half of it, and therefore the answer will be Q by 2 epsilon naught. Do we understand this?
Yes, sir.
So any question, if it comes in this way, you should solve it like this. Do we understand this? Yes or no? No, yes.
Yes, sir.
Everyone has got this.
Yes, sir. Yes, sir. Understood, sir.
Okay. I'll give you one more. I'll give you all these diagrams, and probably you will be able to understand what is the flux through these cases. See, have you understood this concept, bacha?
Yes, sir.
Now see, these are other 3 examples of similar thing. Do you understand? You have to find out the flux through one half of the hemisphere. So what do? You make it full. So the total, so the flux through one half becomes Q by 2 epsilon naught. Do we understand this? Similarly, you have one half cylinder like this, and you have put a charge here. So what you do? You make it 2 cylinders. Do you see here 2 cylinders? One on the top, one at the bottom. Yes or no?
Yes, sir.
So the flux through that part is Q by 2 epsilon naught. If you have a charge placed on a cube here like this, what do? You put one more cube. So the charge, so the flux through one of the cubes becomes Q by 2 epsilon naught. Do we understand this? Yes or no?
Yes, sir.
Are we understanding this? Yes or no?
Yes, sir.
Note it down. Are you noting it down?
Yes, sir.
Please note it down. Noted it down, bacha?
Yes, sir.
Completed, sir.
Huh? Shall we move ahead? Now in this cubes you will have two more cases, and I will give you those two more cases, and I hope you are able to understand this. See this one. Now in the first case that you see over here, the cube is placed at the center of a face. Do we see this? You must have read it in your chemistry. Face center cube. The charge is placed at the center of the face. In this second case, the green case, it is placed at one of the corners. Do you see corners? Now
Yes,
they
sir.
ask you what is the flux through this one entire cube. So what do you do? What do you do here? This is one cube, and the charge is here, one cube. So what do? You put one cube here, 2, one cube here, 3, one cube here, 4, one cube here, 5, one cube here, 6, one cube here, 7, and one cube here, 8. So basically you enclose this, since it has 8 corners, you enclose it by 8 cubes. Do you understand this?
Yes, sir.
And then it comes at the center of this big cube. Do we get this? So the flux through any one of these pieces will be q by 8 epsilon naught. Do we understand this?
Yes, sir.
Similarly, if you put at one of the edges, see, if you put it here, how do I enclose it? If I put it here, I put one cube on the top of this. I have one cube. I put one cube here, and I put one cube here at the bottom. So this will be at the center of these 4 cubes. Yes or no?
Yes, sir.
In that case, your answer would be q by 4 epsilon naught. The flux through any of the cubes will be q by 4 epsilon naught. Do we understand this, bacha?
Yes, sir.
This is what we must remember about flux through cube. In this big case, remember, they can ask you the flux through any of the face, flux through any of the face of the cube. Now, through all these faces, the flux is going to be same. So flux through any of the cubes will be, any of the faces of the cube will be q by 24 epsilon naught. So can you remember this? Do we understand this, what I have drawn here? Yes or no?
Yes, sir.
Okay, these are the maximum questions that can come from this particular topic, the Gauss law. This is all you need to do here at this point in time. So we will wind up this Gauss law with this particular session. Covered all the questions that could have come in your NEET exam. So we'll start with electric potential and potential energy in the next class. If you have any doubts, please come up. Otherwise, take care. God bless all of you. Bye-bye.